Be careful, Dave.
I made the effort with plotting the data for each individual plane as I've shown before. And so let's have a look what it will actually cover. So here we've got the first scenario, which is all of the planes covered and balanced with the total energy consumption of the house. As you can see, even if we covered all of the available roof planes in this building, on this, well, on the premises as well, we would still need additional 117 kilowatt hours and 87 kilowatt hours in December. So January and December would still need some more energy supply. Let's see what it does with just the single 13 kilowatt peak southwest plane covered. As you can see, it's not as nice, but the months of January and December, as well as November, will need some more energy. Next up, I plotted the data against the other consumption of the house, but for the heating and hot water preparation. So basically consumption of everything but for the heat pump. Here the results are very nice. As you can see, even with a single plane covered, we are having a positive balance every single month of the year. And of course, it therefore makes, in this case, not much sense to cover more than the single southwest plane. What you can actually see is how much better the southwest, or well, south at best orientation in the northern hemisphere is against those that are oriented more towards north. As you can see, plane 1 and plane 2 have a similar peak power. We can see it's 13 to 11.5, so in the same realm. However, in general, let's say the southwest oriented produces 4 times more energy than the oriented towards north. And so what we can actually illustrate is that if you were to design a new build, you would probably opt for a different heating source than a heat pump in case you wanted to be fully autonomous. Why? Well, because the heat pump actually consumes a lot of energy, and so you'd be better off with something like a pellet fireplace or maybe a combination of multiple sources. And in this case, you might be asking, hey Dave, so I've got a built house, there's a heat pump, and I'm willing to invest as much as it takes. However, I still want to be fully autonomous. What are the options? Well, in this case, we would be looking at providing the months. So in this case, it would be January, November, and December with some kind of generator. And we could be looking at other renewables. We could be looking at wind potential, which there actually is quite some wind potential in this specific location. However, it's very much varies from place to place. And those are pretty much the options that you have. Is there anything else? We don't want to be running on diesel generators.
Provided that you are running a TNS three-phase system. TNS is abbreviated from the French
Terre neutre séparée,
which pretty much means that the neutral and the ground wire are separate in this type of installation, which is the common installation nowadays.
Now, if anyone came to me and told me that I can save up to what the PVGIS data based on theoretical production is, while offering me a single one-phase inverter and not further expecting the electrical wiring in their house, I would be very suspicious about that. It's very likely not to turn out to be true.
The reason is that the actual savings in that kind of system are limited only to the potential savings for that one phase. So only for the appliances that are actually running on that single phase. Now, if we really want to make the system efficient, and as we've seen, we can make quite a lot of energy from the PV power plant, we will need to either use a single three-phase inverter or set up an array of 3 one-phase inverters that communicate with each other and are able to power each and every phase individually.
In order to illustrate what I meant by that, I prepared a couple of shots that walk you through the way of determining load on individual phases. And to say there are 2 ways to do that. You either have the electrical documentation for the wiring, and you can determine it based on that. Or if you don't have it, come with me, leave your fears, and let's inspect the electrical box. So, option 1, you have a wiring diagram, and as you can see, there are labels coming to the individual circuits or appliances that say that they are either on L1, L2, or L3. There's also another way, which would be depicted as 3 horizontal lines, L1, L2, L3, and then it would be clear which appliance or circuit is connected to which.
If you don't have a wiring diagram, you can actually inspect the electrical box and therefore determine which circuit is connected to which phase, L1, L2, L3, and based on that, you can actually calculate the total power input for the appliances on that phase, on that circuit, and you can sum it for each phase individually. If you're not comfortable doing this, I'd rather you call an electrician because no one wants to get zapped. Now, safety first. No one likes to work with hot wires, although I know one guy and it was me who has worked with hot wires and it resulted in me getting zapped, which I do not recommend. So I'd rather you turn off the RCCB or at best the whole circuit breaker for the whole house in the outside electrical box. I'm gonna do just this, and then I'm gonna use the voltmeter to make sure that I'm not touching any hot wires. Yeah, also like it's good to wear some maybe rubber, what's the name? Some rubber shoes, and don't wear any necklaces and bracelets, stuff like that, you know, that could get tied in there. So yeah, just good. Wasn't expecting that. Gotta untie them. Some are pretty stiff. What you can see is that this thing comes out. Now it's safe, it's all disconnected. Unless it still holds in here. It comes out now. Yep. What I wanted to show you. This link links the phases. And as you can see, they're all in straight line. Let's focus. Yeah. They divide into 3 lines, 3 vertical lines, therefore are divided into individual phases. As you can see, it's right, middle, left, right, middle, left, right. So what this means for us in reality is that those 3 are linked to the same phase, L1. So those 2 are going to be on L2 and those 2 are going to be on L3.
The rest you can determine by knowing the first connection point of that phase and then counting every 2 breakers from that point. Nevertheless, I decided to show you.
Now, if you're using a cordless drill, just use it to loosen them up. It's not very good for tightening them as these have quite high torque, or just set it to a very low setting.
What's also interesting is that actually flathead bits work more effectively with these sometimes, so you just gotta be careful and try out what works best for you.
Now we gotta set our multimeter to volts AC. I gotta bring you closer so that you can see. So each of the phases has a different color, so they're brown usually goes for L1, black L2, and gray L3. And so what you can do is actually measure the voltage in between L1, L2, L1, L3, and L2, L3, which are gonna be, let's see, more than 400. 422 is L1, L2, L1, L3 is 423, and L2, L3 is 426, so somewhere around there. As expected, the neutral to L1 should be giving around 2 Okay, 244, that's a nice voltage here.
What you can do after inspecting it in the way I showed you is you can make an Excel sheet that lays out all the circuits and assigns the individual phases to them. Therefore, you can see what load should be on what phase, and you can go as far as to really determine what you should do, what actual appliances are connected to that circuit, and then you can sum their power input. Now, when designing electrical, the emphasis should be on pretty much balancing the three phases so that their power input should be pretty much the same. However, we can see that there are some additional circuits. It doesn't yet mean that it's going to be there's going to be too much power input on that phase. However, it comes down all to really measuring it and knowing how long the devices run. Now, what I also did is I labeled the circuit breakers. It's not the nicest visually, however, it does the job quite well. You can see that we've got circuit breakers ranging from B2, so type B, 2 amp to type B 16 amp. And we've also got three-phase B16 for some of the three-phase appliances here, and three-phase C20 for the underfloor heating, which is kind of a perk here. As you can see, I already did some the power inputs for each individual phase, and I'm going to show you how to do that in just a moment. However, for now, this is what you can do. And I was previously talking about a more precise load profile, and what you could actually do with this is set up a three-phase load profile with hourly data. You'd have to kind of base it on how you actually behave in the house, and that would give you a very, very clear idea of how much energy you consume, and you could more precisely dimension the battery based on that. Just to quickly show you the underfloor heating, this is based on the documentation which was in this case available. And so the only thing left to do was actually to copy the tables there and assign the phase numbers according to the wiring diagram, which I did. And then after summing it, we can come up with the power inputs for each individual phase. And we also know that the total power input is over 9 kilowatts.
Aha! To byl třeba